What would you do to both sides? Think of it like just like a normal equation. What would you do? Okay, so you would divide both sides by 2, right? I would divide, and in fact, let me make this even easier. Let me make this even easier. Let's say this is 16. So like Perla said, we would divide both sides by 2 to get L by itself, right? So then L equals 8. This is very basic algebra. Now, why did Perla choose to divide by 2? What is that? Okay, so I'm seeing some. Okay, so I'm seeing some answers that are you're all saying the right thing. Let's think about it more deeply. Why did she divide by 2 rather than multiply by 2, add 2, subtract 2? Why did she divide specifically? Okay, so there it is. Because division is the opposite of what? Is the opposite of multiplication, right? So do you guys remember what that's called? That's called inverse operations, right? We were multiplying, we were doing 2 times L, so the opposite, the inverse operation, is to divide by 2. The same thing happens if, for example, same thing happens if you have something like this. If you have 2 plus L, what do I do to both sides? We subtract, right? The inverse operation of addition is subtraction. So we subtract from both sides to get L by itself. So inverse operations with algebra, when you do an inverse operation, you're basically undoing what is being done. You're doing the opposite of what you see. One last example. If I have L to the power of 2, what is the inverse operation of that exponent? Good, yeah, Janelles, you got it. The inverse operation is the square root. So when you take the square root of both sides, we get L equals 4. So there's inverse operations for addition, subtraction, inverse operation for multiplication, division, inverse operation for exponents is the square root. Well, there's also inverse operations for cosine, sine, cosine, and tangent. So in this example, let's go back to it. The inverse operation, and I want you guys to write this down. The inverse operation of each of these, the way that you write it is sine to the power of -1, cosine to the power of -1, and tangent to the power of -1. That's the inverse operations. And we'll talk about how exactly you do those in just a moment. But at this point, that's the most important thing to understand what that is. It's the opposite of taking the tangent would be the inverse tangent. The opposite of doing the cosine is the inverse cosine, and the opposite of doing sine is the inverse sine. So when you have this equation right here, because I'm trying to solve for L, I'm trying to figure out, okay, what is the measure of angle L? In order to do it, I have to undo the tangent. Because right now I'm taking the tangent of L. So if I need to undo that tangent, what I do, Okay, so what I would do is I'm taking the inverse tangent of both sides. Take the inverse tangent of both sides. What that does is it undoes the tangent, and I'm left with L equals the inverse tangent of 35 over 65. Now, this is something that we're going to learn how to do on our calculators. For this entire class, actually, everything we do from this point forwards, you will need your calculator. If you don't have an actual calculator, you can also use a phone, but I definitely very strongly suggest that you have your calculators, start bringing them to school with you if you aren't doing that already, okay? And then those of you who are at home, hopefully you have your calculator there. If you don't have one, you should have one. Definitely you want to have a calculator. But we haven't figured out our final answer yet. But does anyone have any questions up to this point about what the inverse operation is? Cool. Okay. So before we actually get into it, I want to just go over calculators, because this is something where if you do it wrong, if you don't press the right button, we're going to be in trouble. So most of you probably have a scientific calculator like one of these. They all will have the same buttons. They might just be in a different place. But for the most part, they tend to be kind of in the same place. Look for, on your calculator, look for the sine, cosine, and tangent buttons. They're going to say sine, cosine, and tangent on them. So different calculators have them in different places, but they're mostly kind of in the same area. They're going to be somewhere above the numbers. Okay, so look for those. If you're using an iPhone, if you're using an Android, if you're using the Google calculator, you should also see it as well, but you'll have to turn it sideways. So just make sure if you're on your phone, turn it sideways and you should see them. They're right here, sine, cosine, tangent. You can't miss them. So what we're gonna do, the first thing we're gonna do is we're just gonna practice using those buttons. So go ahead and use your calculator to find each of these values. So matter of fact, let me just share my phone screen for a moment so I can show you what it looks like on my phone. So hold on, new share. Okay. Cool, here's my phone. So I have these three buttons, sine, cosine, tangent. Oops, I started pressing them. Okay, so if I'm looking for, the first problem was to figure out what is the sine of 40. The sine of 40, well, I'm just going to, hold on. Oh, something just came up. Okay. I'm just going to press, the first thing you have to enter is the number. So if I'm looking for the sine of 40, I'm just going to put 40 and then hit the sine button. And there's my answer. And we're rounding each of these to the nearest hundredth, so my answer would be 0.64. Same thing, then you have to find the cosine of 40. So the first thing is you put the number, then you press the cosine button, and it'll pop out the answer. So whichever calculator you're using, it'll probably be the same idea. Some calculators, you have to press the button first, and it'll show you some, like it'll make you enter the number afterwards. So just check with your calculator. If you have any confusion or if you're not sure if you're doing it right, just send me or speak out loud or send it to me in the chat and I'll try to help you out. But let me go back to the problems that you guys are going to do. Okay. So again, using your calculators, this is all on your calculators. Figure out sine of 40, cosine of 40, tangent of 40, go all the way down and write the answers in your notebook as well. I'll start off with I'll give you guys like 3 minutes. No, you won't even need 3 minutes. Give you guys 2 minutes. You do not need to type it into the chat. Just make sure you write it down so that when we go over it, you can check your work. In one moment, Jalen. That's what I was gonna do next. So I'm just waiting. I want everybody to do all of them on your sheet of paper, and then once everybody has all their answers, then I'll have you guys annotate it. All right. So as you guys are getting your answers down, you can go ahead and start annotating onto the screen. So you can use the text button or the drawing button, and whatever answer you feel like filling in, go ahead and fill it in at this time. All right, go ahead and put your answers in. Why do I only see one answer? I've given you plenty of time. Okay, good. 0.64. Okay, good. Keep it going. All right, just missing a couple more. Oops. Good. All right, what's the cosine of 50 and what's the sine of 45?
She's 0.71, but my annotate button's over it, so I can't annotate.
Okay, then somebody else. Let's go. And whoever put the sine of 50, just double check that. I would round it a different way. So sine of 50, same with sine of 45. Double check that. Round it to the nearest hundredth. So look again at what you get in your calculator. And how would you round it?
70. I just said 71.
Yeah, it should be 0.71. Because the answer, when you actually type it in, the sine of 45 is 0.707. So we got to round it up. And then the sine of 50, what do you get in your calculator? You get 0.766. So 0.766. If I'm rounding it to the nearest hundredth, do I keep that as a 6 or do I round it up? Yeah, we got to round that up to 0.77. Okay, so just going to fix that. Okay, so there's all our answers. Do we notice any similarities, any patterns? What do we notice? Certain numbers are the same, yeah. So let's look at which ones are similar or the same. Cosine of 40 is the same as the sine of 50. What else? Sine of 45 and the cosine of 45 are also the same. Oops. Okay. Any others that are the same? Good. Cosine of 50, sine of 40. Okay. Cool. Good. Good, good, good. So let's talk about that. Let's think about why that might be true. When else have we realized that the cosine of one angle is the sine of another angle and the sine of that angle is the cosine of the other angle? When else did that come up? Yeah, in the bell ringer, right? In the bell ringer. Well, let's think about it. If you have a right triangle, okay, here's my right triangle. And let's just say this angle is 40 degrees. What does this angle have to be and why? It has to be 50. Why is that? Because of the triangle sum theorem. They all have to add up to 180, which means that A and B are what type of angles to each other? What do you call them? What do they add up to? Just A and B. Good. They are complementary. They are complementary because since you already have a 90-degree angle, with all right triangles, every right triangle, no matter what, since one of those angles is already 90, the other two have to add up to 90. They are complementary. So 40 and 50 are complementary numbers because they add up to 90. And what happens is complementary angles, the cosine of one is going to be the sine of the other one. The sine of one is going to be the cosine of the other one. So for example, let's think about this. The sine of 30 will be the cosine of what number? Of 60. Because 30 plus 60 gives me 90. Those are complementary angles. Let me do another example. The sine of 18 would be the cosine of what number? Good, 72. Because again, those are complementary angles. They add up to 90 degrees. So looking at example G and example H, 45 and 45 gives me 90, right? So if I have a right triangle and one of those angles is 45, then the other angle also has to be 45 degrees, which means that the cosine and the sine of 45 are both going to be the same. They're going to be equal. So that's kind of something we're going to talk about a little bit more tomorrow. But any questions on this page? Any questions on using your calculator too? Did anyone have any difficulty? Anybody got different answers and they're not sure why? You just didn't round it properly. Okay, that's fine. That's another issue. Okay, cool. Oh, let me clear all my, okay. I'm gonna skip this. Actually, no. So what we can do is, because you can use your calculators now, and you can actually plug in numbers and figure out the sign of a number, we can use that to find missing lengths. So for example, here's an example. Sine of b would be the opposite over the hypotenuse. So let's fill in all the blanks that we know and just put an x on any numbers we don't know. So what do I know? Oh, it's not a 7, it's a question mark. Sine of b. Sine of b. So we know b is 50, right? And we're looking at sine of b. So even though, Perla, you're right, a is 40. You're right, but that's not what we're looking for. So we're sticking with b. What's the opposite of b? What's the opposite side? It's the question mark, right? So I'm going to put x there. And the hypotenuse is 6. Well, I can solve for x. What would I do to both sides to get x by itself? Multiply by 6, exactly. So in our calculators, what we can do is we can calculate what is the sine of 50 and then multiply that number times 6. So go ahead and figure out what is 6 times the sine of 50. Good, Pearl got 4.6. Let's round it to the near, oh, you did round it to the nearest. Yeah, this would be 4.6. Did anybody get a different answer? Does anyone want me to show you on my calculator how I do this? You also got 4.6, good. And Jalen, you got 4.59, which is true, but we are rounding it up. So we rounded it up to 4.6. Cool. Now, let's answer this little question. Now that I've found the length of CA, so let me actually, hold on, let me write this a different way. So 4.6 equals x. There we go. So now that we know that x is 4.6, what are 2 different ways that I can now find the length of CB? I'll call this y. What are 2 strategies? Janelle's has one. One strategy is to use the Pythagorean theorem. Good. That's okay. You guys both got it almost at the same time. And then Perla, okay, the sign of B was the opposite side. The sign of B. What do you mean? I'm confused by your question, Perla. That was the side that we were missing. We didn't know what that was our question mark side. So we had that was X, right? Sine of B is opposite over hypotenuse. So we set up our equation. Opposite over hypotenuse was X over 6. Does that make sense? Okay. You're welcome. Okay, so like I was saying, one strategy for finding the missing side is to use the Pythagorean theorem. That's good. Can anyone think of a different strategy that's similar to what we already did? Okay, let's see if that works. Sine of A. What would the sine of A be? Sine of A would be y over 6. Good. And we know that A is how many degrees? A is 40 degrees. So that totally works. You're right. So the sine of 40 is y over 6. I can multiply both sides by 6 to figure out the value of y. So what would be 6 times the sine of 40? 3.86. Good. So see, now we're learning new different ways to do something that when we used to do it with the Pythagorean theorem, you can also use sine trig functions to figure it out. So we were able to use the sine of A. Use the sine of A. Is there another trig function we could have used? We used the sine of A, but what's another? Good, Perla. You could use the cosine of B as well, which are, we know that they're equal. They're the same thing. All right, so let's go ahead and do a similar example. Very similar. We want to find the value of the missing side length using our trigonometry ratio. So in this case, sine of B would be AC over AB. So AC is our missing side. So it's very similar. So this time, sine of 40 is X over 7. So all I need to do to both sides now is multiply by 7. Seven times the sine of 40, we can use our calculators. The sine of 40 times 7, and Perla said, okay, Perla said 4.5. That's good because we got 4. If you use your calculator, you should get 4.4995132, blah, 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 blah. So that simplifies or rounds to 4.5. Okay. Go ahead and find the other missing length. Find the length of y. Pick a function. There's more than one way to do it. So pick one way, see if you can figure it out. Okay, Perla got 5.4. I'm going to give everyone else a moment to try it on their own. Good, Janelle's got the same thing. All right, so let's go through it. If you want to figure out the value of y, which function can I use? Which trig function? Good, we can use the sine of A or we can use the cosine of B because they're going to be the same exact thing. So let's go ahead and do the cosine of B. What goes into my equation for the cosine of B? Good. The cosine is adjacent over hypotenuse. So the adjacent side is 7. The adjacent side is y. And the hypotenuse is 7. So it's y over 7. And now I just need, again, to multiply both sides by 7. So 7 times the cosine of 40. 40. And 7 times the cosine of 40. We use our calculators to find the cosine of 40. Multiply it times 7. And we get 5.36. 5.36. So questions, how do we feel about this? Questions on how I got those answers, how I got those numbers. And Jalen used the Pythagorean theorem and got the same thing. Nice job, see? So now we're learning different strategies to do the same exact thing, to figure out the same exact thing. That's good. Any questions? Can I do what? The Pythagorean theorem? Yeah, sure. Sure thing. So this was our missing side. I'll call this, like we were using y. So for a squared plus b squared equals c squared, I would use 4.5 squared plus y squared equals 7 squared. So 4.5 squared, 4.5 times itself is 20.25 equals 49. Let me move this up a little bit. Subtract 20.25 from both sides. I get y squared equals 28. Oh, thank you, Jalen. 28.75. Take the square root of both sides. And the square root of 28.75 is 5.36. So we got the same exact answer. Cool? Questions? Okay. One more on your own. So this time I'm not showing you which ratio you should use. Pick the ratio that makes the most sense for this problem. You could use cosine, sine, or tangent, but one of them is going to be the best one. It's a little trickier, isn't it? I'm going to give you guys about 30 more seconds. This one is a little more tricky. I want to see if anyone can get it. Okay. Which function is going to be the best? Sine, cosine, or tangent? Maybe tangent. Okay. Well, I have a number over here. I have an unknown over there. And I have angle E. Which function is going to be using the 4 and the question mark, or the unknown? Let's call it X. Good, Janelle's. That's cosine, because the cosine is adjacent over hypotenuse. So you want to pick the function that includes those two sides. The tangent would include the 4, but then it would include this side as well. And we don't care about DF right now. That's not what we're looking for. So since we're looking for DE or X, I need to use cosine, okay? Because that one uses my adjacent as well as my hypotenuse. So the cosine of E is 4 over X. Okay, now I'm going to fill in what I know. I know E is 55 degrees. Okay, but this is a little different. It's a little bit different than our previous problem because now the X is in the denominator rather than the numerator. So let's think through this for a moment because there's kind of a trick to it. I need to get that X out of the denominator. In order to solve for X, it's got to come out of there. What can I do to both sides to bring it out? Okay, we can multiply by the reciprocal. So what you really want to do, think about in the previous problem, what did I do to get this 7, to get my 7 out of the denominator? Multiplied it out, exactly. So in this case, we're going to do the same thing. We're just going to multiply by X, just X, on both sides. Because what that does is that brings my X out of the denominator and brings it to the opposite side. So now I have X times the cosine of 55 equals 4. But I need X to be by itself, so what should I do to both sides to get X by itself? Yeah, we're just going to divide both sides by the cosine of 55. Because it's going to cancel those out, and I'm going to be left with X. Well, that just means that now I have to do 4 divided by the cosine of 55. So when you use your calculator, you're not going to multiply it by 4. You're going to be doing 4 divided by the cosine of 55. And when you do that, you're going to want to be very careful. So actually, I'm going to share my screen again, share my phone screen. We're doing 4 divided by the cosine of 55. So, okay. So what we need to do, oh, hold on, it's not loading. Come on. Okay, it's loading kind of slowly, so give it a moment. But what we need to do is when you divide by the cosine of 55, you want to use parentheses, because if you don't use parentheses, it's going to think that you're looking for the cosine of 4 divided by 55. So it's kind of, you know how there are parentheses around the 55? We want to use those parentheses. So watch carefully what I'm going to do. I'm doing 4 divided by the cosine of 55. So 4 divided by parentheses, so open parentheses. Now I'm going to type in the cosine of 55, 55 cosine. Then I need to close my parentheses, so I'm using the close parentheses button. And after you close your parentheses, you have to hit equals. And I get 6.97. Is it still frozen? Oh, it's still frozen. I don't know why it does that. Okay, now it's just gonna, in like a couple of seconds, I bet it's just gonna do it all really fast. So give it one moment. Okay, it just disconnected. Oh well. Well, I tried, but the worst comes to worst, what you can do is just do the cosine of 55, get an answer. So matter of fact, let's do that. What is the cosine of 55? Just use your calculator. What do you get? What's the cosine of 55? Okay, there you go. 1? Where are you getting 1 from? You put in the wrong value. Okay. 0.57. So all you got to do is 4 divided by 0.57. Go ahead and try that and see what you get. $7.01, right? Okay. So any questions on this problem? It's just a little bit different, so it kind of involved a couple of more steps compared to the previous one. All right, one more, actually 2 more. Go ahead and work on these for about, I'll give you guys about 3 minutes, and just follow that same process. Figure out which ratio, which function is going to be the best one to use. Set up your equation, and then solve it using inverse operations. Yes, Perla, you can just send me them in the chat, please. You're not supposed to be doing the Pythagorean theorem right now. You can't, because in order to do the Pythagorean theorem, you need 2 side lengths, and right now you only have 1. Again, send me your answers in the chat when you've got it. All right, so I hope that I don't need to do a repeat of yesterday because I really don't want to have to do that again. But if I don't have people sending me answers, then I'm just going to assume that everybody is lost and doesn't know how to do this. Is that a correct assumption? Everybody let me know in the chat right now. I know how to do this, or I do not know how to do this. I need an answer from every single individual at this moment. You do not have to send it on public. Send it. Let's go. I'm waiting. I've only seen 2 answers, guys. Let's go. Do you know how to do this or do you not know how to do this? There's only one answer. If you do you know how to do this or do you not know how to do this? And if you don't know how to do this, then where are the questions? If you are staring at your screen blankly, that is a bad thing. If you're staring at your piece of paper blankly, that is a bad thing. If you are not asking me questions, you are not taking the initiative that you need to be taking in order to understand. I can't be sitting in front of you looking at your sheet of paper. I don't know what you're doing behind your screen, especially because nobody in this class likes to have their cameras on. Now, I've been very lenient with that. In theory, everybody is supposed to have their cameras on at all times. But if you're not going to give me the feedback that I need as your teacher, then I can't do my job properly. And if you're not going to ask me questions, then how in the world am I going to know if you're confused or not? How? Can I look through your computer screen? No, I can't. So I'm very disappointed at this time that I have not had a single question in the chat from the students that don't know how to do this. Because that means that you're not taking your own responsibility that you need to be taking in this class. You all know that this class is not an easy A. And if you don't take that initiative, then you're never going to pass the class. And it's very frustrating to me when I only have one student out of 9 participating. So I'm going to ask one more time. Who is still confused? Then I'm going to go back to the problems we already did and teach them once again. And once I teach them, I expect everybody to know how to do them, because once I teach them, that was your chance to understand. And if you still didn't get it when I finished this problem, you should have let me know. But since nobody asked any questions, I moved on. And when I move on, I'm assuming that you know how to do it perfectly. Don't let me move on to the next page if you do not know how I did that problem. Because it happened yesterday and it was about to happen again today. I was about to pop out another pop quiz on y'all. Because that's the way you guys are acting. I don't understand. It makes no sense to me why I have a room full of students and nobody wants to ask me any questions. That does not make any sense to me. I'm going to keep the screen completely blank because when you get a problem like this, the first thing you have to figure out is which ratio you want to use. I have 2 side lengths that I'm looking at. One of them I know 7. One of them I don't know. I don't know this one right here. And I have one angle measurement, that's angle B. Which ratio includes those 2 sides? Which ratio? Is it the sine, cosine, or tangent? Sine. Sine because we need to use the hypotenuse and the opposite side. Which one is the opposite side? CA. That's our unknown. And the hypotenuse is 7. So the sine of B is x over 7. Up to there, basic stuff. Haven't done anything crazy yet. Now I'm just going to fill in because I know that B is 40 degrees. So I'm going to fill that in. At this point, it's basic algebra. I am solving for x. That's all I'm doing. To get x by itself, what do I do to both sides? Multiply times 7. use your calculator. You can't do this without I can't do this without a calculator. Mr. St. Rose, Ms. Deriscar, nobody can do this without a calculator. You have to use it. Because now we're just going to do 7 times the sine of 40. In your calculator, plug it in. What is the sine of 40? Get an answer, multiply it by 7. So you should get 4.4999 something, 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 so it rounds up to 4.5. With every single question that you get that looks like this, step 1, figure out which ratio you want to use. Step 2, fill in all the information you know. Step 3, use algebra to solve for x. That's all it is. It's 3 steps. Figure out the ratio, put all of your information into the ratio, solve for x. Well, you have to use the ratio that makes the most sense. So let me go to one of these problems. In this one, number 1, you have 65 degrees, that's your angle. Then, what do you have from this angle? Do you have the opposite side or the adjacent side? We have the opposite, right? The question mark is the opposite side. So which ratio, if I have the opposite and the hypotenuse, which function should I use? Sine, cosine, or tangent? There you go. Okay, so on every question like this, the first thing is figuring out which ratio, which function you need to use. Okay, so go from there. And again, if you're staring blankly at your screen, that is not good. You have to ask me questions if you're stuck. That is how this works. That is how this relationship has to work, because otherwise, I won't know you're stuck. I won't know. So please, I need you all to be a little bit more responsible with your own learning. I am your teacher, but that doesn't mean that I know exactly what's happening in your head. You have to let me know. So go ahead and give it a try. Round to the nearest hundredth. Okay, I see most of you finished number 1, so I'm going to quickly go over it. Sine of 65 equals x over 6. So I multiply both sides by 6. Now, when you get your answer on your calculator, make sure you're rounding correctly. The sine of 65, I get 0.9 0.063, something really long, times 6, I get 5.4378. So if I'm rounding to the nearest hundredth, what do I get? Do I get 5.43 or 5.44? Good, 5.44. Okay, so that was number 1. Now in question number 2, you're looking for ty. So go ahead and finish number 2 if you haven't done so yet. All right, for number two, with which function should I be using to find my answer? Okay, so careful, Tyrone, because cosine would be 3 over the hypotenuse, but we don't know the hypotenuse. That's not what we're concerned with. We're concerned with the opposite side. So I have the opposite side and the adjacent side. So I need tangent. So I need tangent because that's opposite over adjacent. So the tangent, what did I write? Sine, I don't know. The tangent of r is x over 3. Fill in everything you know. So the tangent of 37 is x over 3. And we're multiplying both sides by 3. Using your calculator, go ahead, get an answer, and round it to the nearest hundredths. 2.26. Careful, Tyrone, you just rounded it to the nearest tenths place. But we're rounding it to the nearest hundredths place, because what's the long number you end up getting? The tangent of 37 times 3, the long number you get is 2.6, oh my goodness, 2.2606. So if I'm rounding to the nearest hundredths place, that's the 6, it stays a 6. You don't round it up. Questions? Quick reminder, there was a question in the chat, so I want everyone else to answer it for me. How do you know which side is opposite? How do you know which side is adjacent? If I'm talking about angle A, how do you know which side is opposite? Where do you look? Okay, so Tyrone says it's the one below. So in other words, whichever angle you're talking about, you always look across. So this is my opposite side. And the one that's directly next to that angle, so right next to it, is adjacent. So opposite, you go cross, right next to is adjacent. And then hypotenuse, good, Tyrone. For hypotenuse, you always look at the longest side. The longest side is the hypotenuse. But Jalen, be careful because adjacent isn't always the smallest one. It's not always the smallest. Like, for example, let me see. Look at the first example. In the first example, let's say I'm looking at angle B. Which side is adjacent to angle B? The question mark side, right? CB is adjacent, and AC is opposite. Okay? Because it's a cross. So that's how you always check. Go directly across, that's your opposite side. Right next to is adjacent. The longest side is the hypotenuse. All right, y'all. So we didn't get to everything, unfortunately. However, tomorrow there's 2 assignments on Khan Academy that most of you, except Daniel, you did one of them, but most of you didn't do them yet. Don't do them for homework because you're going to be doing them during class tomorrow. So there are assignments, don't worry about them. Don't even try them yet because I want you guys to be doing them during class tomorrow. And then that'll be that for Friday, okay? So no homework tonight except for the homework that I assigned on Monday, which most of you did, but a lot of you didn't do it yet. So make sure that you complete that assignment. It's on Teams. You have to send me a picture. It's about what we learned in class on Tuesday. Okay, so don't forget to do that. That's due tonight at midnight. I'll see you guys tomorrow. Have a good day, everyone.